Look up into the night sky. On any given clear evening, you might spot a brilliant, unwavering point of light. It doesn't twinkle like the distant stars. It shines with a steady, serene glow. This is Venus, our nearest planetary neighbor. For centuries, we looked upon it with wonder and named it after the Roman goddess of love and beauty. It's almost the same size as Earth. It has a similar mass and is made of similar rocky materials. For these reasons, we often call it Earth's twin. But if Earth is our home, a cradle of life, then Venus is our twisted sister, a world of unimaginable fury and danger, a vision of what a paradise can become when things go terribly, terribly wrong. Imagine a world shrouded in a thick yellow blanket of clouds. These clouds are not made of water vapor like our own. They are composed of droplets of corrosive sulfuric acid. They move with incredible speed, whipping around the planet in just 4 Earth days, driven by hurricane-force winds. Below this toxic veil lies a surface completely hidden from our view, a secret world that tantalized astronomers for generations. What lay beneath? A lush tropical world, a global ocean? The truth, as we would discover through great sacrifice and ingenuity, was far more extreme and far more terrifying than anyone could have possibly imagined. It is a world that challenges our understanding of planetary evolution. The story of Venus is a story of extremes. It is the hottest planet in our solar system, even hotter than Mercury, which is much closer to the Sun. Its surface temperature is a staggering 462 degrees Celsius, hot enough to melt lead. The pressure at its surface is over 90 times that of Earth's at sea level. Standing on Venus would feel like being crushed under nearly a kilometer of ocean water. It is a planet that has experienced a runaway greenhouse effect, a cautionary tale written on a planetary scale. This is not the gentle twin we once hoped for. It is a vision of a planetary apocalypse, a world that pushes the very limits of exploration and endurance. This celestial body, so similar to our own in its basic composition, took a drastically different path. While Earth developed into a haven for life, with temperate climates and liquid water, Venus became a veritable furnace. Understanding why these two sibling worlds diverge so dramatically is one of the greatest quests in planetary science. It forces us to ask profound questions about our own planet. How fragile is our own climate? Could Earth ever suffer a similar fate? Venus is not just a destination for our spacecraft, it is a mirror reflecting a potential, albeit extreme future for our own world, a silent warning hanging in our sky. Before the dawn of the space age, our imaginations ran wild with possibilities for Venus. Peering through telescopes, astronomers could see only the impenetrable layer of clouds. They knew Venus was closer to the Sun than Earth, so it was logical to assume it would be warmer. But how much warmer? The thick cloud cover, they reasoned, might reflect a great deal of sunlight, perhaps creating a pleasantly warm, humid environment. Science fiction writers and even some scientists painted a picture of a world teeming with life. A younger version of Earth, perpetually misty and damp, a place of sprawling swamps and lush tropical jungles. These were not just idle daydreams. They were based on the best available science of the time. Some speculated that the entire planet might be covered by a global ocean of seltzer water, fizzy with dissolved carbon dioxide. Others envisioned a world populated by exotic creatures, perhaps akin to the dinosaurs that once roamed our own planet during its steamy prehistoric eras. Venus was the great unknown, a tantalizing mystery box wrapped in a cloudy veil. It was the next logical frontier after the moon, a world that seemed so welcoming and Earth-like from a distance. The hope was that we would find a vibrant, living world waiting to be discovered. The promise of a watery, life-bearing Venus was a powerful motivator for the first generation of space explorers. It was seen as a potential second home for humanity, or at least a place where we could study a completely different biosphere. The narrative was compelling. A sister planet, shrouded in mystery, possibly hiding vast oceans and exotic life forms. This romantic vision of Venus persisted for decades, fueling the desire to send our first robotic emissaries to pierce the clouds and see what truly lay beneath. The public and the scientific community alike were captivated by the idea of a primeval world next door. But science is a process of discovery, and discovery often means replacing beautiful theories with harsh realities. The idyllic image of a swampy, jungle-covered Venus was about to be shattered. The first robotic probe sent to fly past our neighbor would begin to peel back the layers of this mystery, and with each new piece of data, the dream of a tropical paradise began to evaporate. The truth would prove to be far more hostile and far more fascinating. The stage was set for a dramatic confrontation between our dreams of Venus and the planet's brutal reality. While the United States set its sights on the moon, another superpower had its gaze fixed firmly on Venus. The Soviet Union, a titan of the early space race, embarked on one of the most ambitious and grueling campaigns in the history of planetary exploration, the Venera program. Their goal was audacious and simple: to be the first to land a probe on the surface of another planet. They were driven by a fierce determination to conquer this new frontier, but Venus would not yield its secrets easily. It would fight back with a ferocity that no one had anticipated, demanding a heavy price for every inch of progress. The early years of the Venera program were a litany of heartbreaking failures. Probe after probe was launched, only to be lost to the unforgiving void of space or the crushing embrace of Venus itself. The first attempt, Venera 1, launched in 1961, successfully left Earth's orbit, but contact was lost long before it reached its destination. Subsequent probes failed during launch, or succumbed to the harsh environment of interplanetary space. For years, the Soviets launched their machines towards the shrouded planet, and for years, they were met with silence. It was a brutal and costly learning process, a testament to the immense difficulty of space exploration. Each failure, however, was a lesson. Soviet engineers were relentless. They would analyze the telemetry from a failed mission, identify the problem, and redesign the next probe to be stronger, more resilient. They were grappling with problems no one had ever faced before. How do you build a machine that can survive a journey of millions of kilometers and then plunge into a completely unknown atmosphere? They had to build spacecraft that could withstand the vacuum of space, the intense radiation from the sun, and then an atmospheric entry of unimaginable violence. Their persistence in the face of repeated disaster was nothing short of heroic. This relentless pursuit was a hallmark of the Soviet space program. They refused to give up. Where one probe failed, another would follow, strengthened by the knowledge gained from the last. It was a brute force approach to exploration, a war of attrition against the planet itself. They were determined to plant their flag, metaphorically speaking, on the Venusian surface. This unwavering resolve, this stubborn refusal to accept defeat, would eventually pay off. The Soviet Union was locked in a cosmic battle with Venus, and after years of struggle, they were on the verge of a breakthrough that would change our understanding of the solar system forever. The first clues about Venus's true nature came not from a lander, but from a flyby. In 1962, NASA's Mariner 2 spacecraft skimmed past the planet, its instruments scanning through the thick clouds. The data it sent back was, honestly, shocking. It revealed surface temperatures that were incredibly high, far hotter than the boiling point of water. This was, in a way, the first nail in the coffin for the theory of a lush, tropical Venus. The dream was beginning to crumble, replaced by the first hints of a planetary furnace. The data was so extreme that some scientists were, skeptical, but it was a sign that our neighbor was hiding a very dark secret. The Soviet Union's Venera mission soon confirmed Mariner's disturbing findings, and then some. In 1967, Venera 4 became the first probe to enter the atmosphere of another planet and send back direct measurements. As the capsule descended under its parachute, its instruments painted a pretty grim picture. It measured the composition of the atmosphere, finding it to be almost entirely carbon dioxide, a potent greenhouse gas. It also recorded blistering temperatures and crushing pressures that increased dramatically as it fell. The probe was ultimately destroyed by the immense pressure long before it ever reached the surface, but its sacrifice was not in vain. It had given us our first direct taste of the Venusian hellscape. The data from Venera 4 and its successors, Venera 5 and 6, forced a complete rethink of Venus. The reason for the extreme heat was now clear: a runaway greenhouse effect. The thick carbon dioxide atmosphere acted like a planetary blanket, trapping the sun's heat and preventing it from escaping back into space. This created a vicious cycle where rising temperatures caused more gases to be baked out of the rocks, which in turn trapped even more heat. Venus was not a young tropical Earth. It was a terrifying example of a climate system gone haywire, a world cooked under its own atmosphere. These early missions were a harsh reality check. Soviet engineers now understood the true scale of the challenge they faced. To land on Venus, a probe wouldn't just need a heat shield for atmospheric entry. It would need to be built like a deep-sea submarine to withstand the pressure and have a sophisticated cooling system to survive the heat, even for just a few minutes. The planet was actively trying to destroy anything that entered its domain. The romantic vision of Venus was well and truly dead, replaced by the image of a hostile, violent world. The quest was no longer about finding life. It was about surviving long enough to send back a single signal from the surface. After years of failures and partial successes, the moment of triumph finally arrived. On the 15th of December, 1970, a new, far more robust Soviet probe named Venera 7 plunged into the Venusian atmosphere. It was built like a tank, designed to withstand pressures and temperatures far beyond what had destroyed its predecessors. The descent was harrowing, and for a while, it seemed the mission had failed. The parachute appeared to have failed during the final descent, causing the probe to hit the ground hard. But then, a faint signal was detected. For 23 precious minutes, Venera 7 transmitted temperature data from the surface, becoming the first human-made object to successfully land on another planet and send back information. History had been made. This breakthrough really opened the floodgates. The Soviets, now armed with the knowledge of how to survive on Venus, sent a series of even more sophisticated landers. In 1975, Venera 9 and Venera 10 arrived, each carrying a precious cargo, a camera. After their dramatic landings, they did something no one had ever thought possible. They took the first pictures of the surface of Venus. The images were grainy, black and white, and distorted by the fisheye lens, but they were revolutionary. They revealed a desolate, rocky landscape, strewn with sharp-edged, flat stones under a gloomy orange sky. We were no longer just imagining the surface of Venus, we were seeing it with our own eyes. The pinnacle of the Venera program came in 1982 with Venera 13 and 14. These landers were the most advanced yet. They not only carried color cameras, providing breathtaking panoramic views of the alien terrain, but also a suite of new instruments. A robotic arm drilled into the Venusian soil, collecting a sample, and bringing it inside the lander for analysis. For the first time, we had a chemical breakdown of the rocks on Venus, confirming they were similar to terrestrial volcanic basalt. Venera 13 also carried a microphone, and it captured the first and only sounds ever recorded on another planet. The faint rumble of the wind and the noise of the lander's own machinery. These missions were a spectacular, albeit brief, success. Venera 13 survived for an astonishing 127 minutes in the hellish conditions, far exceeding its planned 32-minute lifespan. It sent back a treasure trove of data, color images, soil analysis, atmospheric readings, and even sound. It was an incredible feat of engineering and a testament to the Soviet Union's persistence. Through the Venera program, they had lifted the veil on Venus, transforming it from a point of light in the sky into a real, tangible place. A terrifying, inhospitable place, but a place we had finally reached and touched. The triumphs of the Venera landers really underscore the sheer brutality of the Venusian environment. The reason no lander has survived for more than a couple of hours is simple. Venus is actively trying to melt, crush, and dissolve anything that lands on its surface. The first and most immediate threat is the heat. With surface temperatures hovering around 462 degrees Celsius, it's a world where metals like lead, tin, and zinc exist as puddles. The electronics inside a spacecraft, even one that has just traveled through the cold of space, will quickly begin to cook. The Soviet engineers had to design complex cooling systems, but these were only a temporary stay of execution against the relentless, planet-wide oven. Then there is the pressure. The atmospheric pressure on the surface of Venus is about 92 times that of Earth at sea level. This is the equivalent of the pressure found nearly 1 kilometer beneath the surface of our oceans. Any spacecraft landing there must be built like a deep-sea bathyscaphe, with a spherical titanium hull designed to resist being imploded. The Venera landers were, in essence, armored spheres. This immense weight of the atmosphere is really difficult to comprehend. It doesn't just press down, it presses in from all sides, a relentless physical force that seeks out any microscopic weakness in a structure and exploits it catastrophically. As if the heat and pressure weren't enough, the atmosphere itself is a toxic and corrosive chemical soup. While the lower atmosphere is clearer than the upper cloud decks, it's still a hostile place. The atmosphere is over 96% carbon dioxide, with traces of nitrogen and other gases. But most dangerously, the clouds that shroud the planet are made of concentrated sulfuric acid. While these acid clouds float high above the surface, they create a virga of acid rain that evaporates before it reaches the ground. This process infuses the entire atmosphere with corrosive compounds, ready to attack the metals and materials of any visiting probe. Surviving on Venus is therefore a multifaceted engineering nightmare. A lander must be a refrigerator, a submarine, and a chemically resistant vessel all at once. And it must achieve all this after being thrown at the planet at thousands of kilometers per hour. The short lifespans of the Venera landers were not a sign of failure, but a testament to just how difficult it is to operate there. Every minute of data was a victory snatched from the jaws of a world that is fundamentally hostile to machines, let alone life as we know it. The planet itself is the ultimate barrier to exploration. After the incredible successes of the Venera and Vega missions in the mid-1980s, something strange happened. We stopped trying to land on Venus. The Soviet Union, the only nation to have ever accomplished this feat, dissolved a few years later, and with it, the political will and financial resources for such an ambitious program vanished. The United States, having focused on Mars with its Viking landers, saw the red planet as a more hospitable and potentially life-bearing target. Mars was cold, but it was survivable. Venus was a machine killer, offering diminishing scientific returns for an ever-increasing cost and risk. The cosmic spotlight shifted. The priorities of space agencies around the world moved towards destinations that seemed more promising or achievable. Mars offered the tantalizing prospect of finding past or even present life, with an environment that, while harsh, was manageable for long-duration robotic rovers. The outer solar system, with its gas giants and icy moons like Europa and Enceladus, held the promise of subsurface oceans and exotic chemistry. Venus, by contrast, seemed like a dead end. We had seen the surface, we had analyzed the rocks, and we understood the crushing environment. The question became, what more could a short-lived lander tell us that would justify the immense expense and engineering challenge? So, Venus became the forgotten frontier. Orbiters like NASA's Magellan continued to study the planet from above in the 1990s, using radar to map its surface in stunning detail, revealing vast volcanic plains and towering mountains. But no one has attempted to touch the ground since the Soviet Vega 2 probe in 1985. The planet remains an untamed wilderness, a world we have visited but have never truly explored. The challenges that the Soviet engineers faced in the 1970s remain just as daunting today. Building a lander that could survive for days, weeks, or even months on Venus would require a revolution in high-temperature electronics and materials science. Yet, the allure of Venus remains. It is a vital piece of the puzzle in understanding how Earth-like planets can evolve. It stands as a stark warning of the consequences of a runaway greenhouse effect, a lesson more relevant today than ever before. It is the ultimate challenge for our robotic explorers, a test of our ingenuity against the most extreme environment in the inner solar system. For now, Venus waits, shrouded in its toxic clouds, its fiery surface untouched by human technology for 4 decades. It is the untamed sister world, so close and yet so incredibly hard to reach, a challenge waiting for a new generation of explorers bold